Hi guys, welcome back to my YouTube channel. In today's video I'll be discussing on derived quantity. So let's start. Guys, pick up your notebook and your pen, pay more attention. There is no confusion, and I'll make sure I break it down in the simplest way possible just for your own understanding. So let's learn together. So today we are discussing on derived quantity. And one thing you should know about derived quantity is that derived quantities are quantities that are formed by combining fundamental quantity using mathematical operations like multiplication and division. So if you have not watched my last video before this video, please go and watch it. I said something about fundamental quantities. So I will do a recap by showing you guys what fundamental quantities are. So in my last video I made a video like this. These are fundamental quantities. We have the length, the mass, the time, the electric current, temperature, amount of some substance, luminous intensity. So from here, these are fundamental quantity. From here we can get our derived quantity. So guys, let's solve some examples together. Let's go guys. So from here we can derive any quantity we want. So for examples. Number one, the first one, velocity. Velocity is a derived quantity. Then velocity is distance over time. This is a formula for velocity, distance over time. So what is the SI unit for distance? We have meters per. What is the SI unit for time? That is second. So our velocity gives us, so our SI unit is either meter over time, or you write it in this form. These are SI units. So velocity is derived from length and time. So let me show you guys. You can see from here, you can see where we derived our quantity. Distance has to do with length, and that is meter. Then time, the SI unit for time is second, and this is how we came about, and this is how we come about our answer. So let's try another example guys. The second example is acceleration. What is acceleration? Acceleration is change in velocity over time. This is our acceleration, change in velocity over time, or change in velocity per time. So from our fundamental quantity we can identify this. Remember, our first example was velocity. What was our unit? We got meter per second. This was our unit for velocity. So now we impute it here over, what is our unit for time? That is S, that is second. Mathematically we have meter per second square, and this is our SI unit for acceleration. So you can also say that acceleration is derived from length and time. So let's try the third example. You will see we are trying something different now, using different quantity. So let's try another example. We have the third example is force. We have that F is equal to mass times acceleration. this is mass and this is acceleration. So from our fundamental quantity, what is the SI unit for mass? SI unit for mass is kilogram. So we say we have kilogram multiplied by acceleration. We have gotten our acceleration. Look at the second example. We have gotten acceleration, so we multiply it through meter per second square, which will give us kilogram meter per second square. And this is our the fourth example. We have density. Formula for density is mass over volume. So from here, what is the SI unit for mass? We have kilogram. We can rewrite volume in this form: length cube, cubic length. This cubic length is something as length times L in 3 form. So this is length. Now length is, what is the SI unit for length? That is meters. So we impute it. We say our density is kilogram per meter cube. So that is our answer. You can see it is derived from mass and length. So guys, if this video helped you, don't forget to subscribe, like, comment and share with a friend who have difficulties in fundamental and derived quantity. See you guys in my next video. Thank you.